Hi everyone, in this video we'll be recalling two of the identities that we have earlier read and learned in the previous classes, namely a plus b the whole square and a minus b the whole square. Now, why are these two identities important? Because these two identities serve as a base to learn whatever's coming ahead and whatever new identities that we'll learn in this standard. To start, we'll be using a new visualization metric to understand these two identities, which you might have not used before in your earlier classes. And this will be like visualizing the area of a square to solve these identities. Since we are talking about a plus b the whole square, the word square does mean something and it does represent something. So with that, let's just start with a plus b the whole square. If you see the diagram on the right, you can easily observe that I have 3 to 4 squares here. So first one, if you just notice, this is a square, which is a square of side A, and the area becomes a square. On the bottom, there's a square of side B, which is b square. So what I want to find is the area of a plus b, a square which has a side of length a plus b. So if I put a square of side A and a square of side B together, this is how they will look, right? This is how they will look, and their side will be a plus b. So this is the side of length a plus b. Now if I want to calculate area of this square, how will I go ahead with it? So first let's see what's the side of square. Side is equal to a plus b. And as we know, area of square is side square, a plus b square, which is side square, right? So the area is a square, this component, plus b square, component on the bottom right? And then we have two more components. This is AB, which is this side is A, this side is B. So this is a rectangle of length A and breadth B, and the area of rectangle is length into breadth. So here the area will be AB. Similarly for this here as well, length is A, breadth is B, the area will be AB. So if I divide the whole bigger square of side A plus B into 4 parts, I can see they are a sum of A square, B square, AB plus AB. Now let's simplify this further. We'll get a square plus b square plus 2ab. And this is equal to our side square, which is a plus b the whole square. And this is our first identity. It's very important you understand the diagram on the left side and then the identity on the right side, because this is how you actually understand why the identities LHS is equal to RHS and why do we have an extra 2AB component in this very identity. To solidify this visualization and the concept further, we'll be also talking about a minus b the whole square, and this will have a very similar diagram to what we had in a plus b the whole square. So if you see on the left hand side, we again have this diagram. This time the diagram is a bit opposite. We have a bigger square of side A and we have a smaller square of side B. Earlier the smaller square was of side A in the middle, but now we have a square of side B enclosed in side A. So if I want to calculate, so this side is A minus B, this is B. If I add these two, this becomes A minus B plus B is equal to A. So this entire side is of side A, this side is B, right? Now I want to calculate the area of the middle square. So I'll just highlight that area. I want to calculate this area, right? So to calculate this area, what we need to do, we need to calculate a minus b the whole square. Again, we take the area approach. Bigger square is a, so we have to subtract from a square. A square is the larger area. Now what do I need to subtract? I need to subtract this minus b square, and I need to subtract these two rectangles. Now in these two rectangles, if you notice, we have breadth of b and the length is a minus b, because the whole length is a. If this is b, then this becomes a minus b, right? So the area for this rectangle would be length into breadth, which is b into a minus b. So it will be minus b into a minus b, and similarly there'll be a similar rectangle on the bottom, which will be minus b into a minus b. Now let's simplify this a bit. A square minus b square minus ab plus b square minus ab, and this will be plus b square. These are plus b square because the minus and minus becomes plus when we multiply. So minus b into minus b is plus b square. Now let's simplify it again. Minus b square and plus b square get cancelled. This will get added. A square will remain as it is. So it's a square minus 2ab and 1b square remains plus b square. So this will be a square plus b square minus 2ab is equal to a minus b, the whole square, and this is our answer. Very important to visualize this metric, because if you just cram it like, okay, a plus b whole square is a square plus b square plus 2ab, a minus b whole square is a square plus b square minus 2ab, you won't reach anywhere. You need to understand why is there an extra 2ab component and why is there a extra minus 2ab component in both these identities. In one identity, we are adding two squares and seeing what the resultant square's area would be, and in the second identity, we are subtracting a smaller square from a bigger square to come to the area of a smaller square. So these two identities are very important from a geometrical sense, and this will help you visualize a lot of identities when we move ahead in the video series. Thanks for watching this. I'll see you in the next one where we practice the questions based on these two identities. Cheers.